This project is about enhancing retail strategy using GMM-based customer segmentation. There are two definitions about Gaussian mixture model and clustering. Searching from Kaggle or other sources like Amazon Open Data. Here I chose to search in Kaggle. Enter the retail. Click the dataset. 7 years ago, I prefer the new one, so the next, we can see the introduction of this dataset. And some samples. Download it. Now continue to data preprocessing. As you can see, cleaned up the data by filling in missing values in numeric type columns and removing duplicates and negative sales records. The graph shows distribution of sales for the next step. Here is the code of data processing. The first step, data clean. I've output the first 5 lines of data here as a preview, as well as to see the type of data, and to clean up outliers, null values, and so on in the next steps. And getting the data type helps us choose the right data more quickly when applying the model later. Save the clean data and try to output it to check if it is complete. Exploratory data analysis. In this part, it shows the distribution of profits and the total sales by category. Specific details are as follows. We can also use a description to see the data on the graph in numerical terms. From this figure, we can conclude that high sales of technology products may reflect higher unit prices or high demands such as electronics, which typically cost more and demand continues to grow. The higher sales of furniture may be due to the relatively high price of the furniture product itself, and the purchase frequency is low but the single purchase amount is larger. Despite the lower unit price, frequent purchases of office supplies may add up to considerable total sales due to the nature of their daily consumables. The correlation matrix shows the relation between, for arguments, sales, quantity, profit, and discount. From this graph, we can see the sales and profit have higher correlation than others. Other specific analyses are shown on the right. In a heat map, the color depth of each cell indicates the magnitude of the correlation coefficient and is usually used in conjunction with color bars or color legends to make interpretation more intuitive. In this project, I chose the cool-warm spectrum, which is usually 2-color, with a neutral color such as white in the middle, and gradually darker colors on both sides, indicating a change in correlation coefficient from positive to negative. This table shows the sales and profits in different regions and product categories. We can also use box charts to visualize the distribution of the data and specifically check for outliers. Then we need to choose clusters. There are several approaches we can take, starting with the silhouette score. A higher positive value indicates better clustering and a close to 0 or negative value indicates poor clustering. This pattern suggests that 5 clusters offer the most effective clustering result. The second way is using BIC-VIC. From this graph, we can see when there are 20 clusters, they reach the lowest, that is the best. However, from the previous method, 5 is the optimal. So which one would be more suitable? We need another way, elbow method. As this graph shows, from 4 to 5 clusters, the decline rate begins to slow down. Considering these 3 methods mentioned above, the optimal choice for the number of clusters is determined to be 5. Next, model training. Here I chose scatterplot. Gaussian mixture was used to set the number of components clusters to 5 for the standardized data, and the fitting was performed. The mean of each cluster center is obtained from the GMM model and the coordinates of these centers are converted from the standardized form back to the original sales and profit scale. This is done by scaler.inverse_transform. Plot raw data points and cluster centers using Seaborn scatterplot. Data points in DF are colored according to their cluster label cluster to show different clusters. Cluster centers are highlighted with red dots. To see the distribution of cluster centers more directly, statistical summaries can be used for analysis. Cluster 0 features consumers who may represent small purchases do not enjoy any discounts. Cluster 1. This group may involve clearance or high discount sales with low sales but frequent transactions and a negative profit, indicating that this may be a loss-making sale. Cluster 2 may represent ordinary consumer groups, buy low to medium value goods, and enjoy a certain discount. Cluster 3 may represent corporate users or bulk purchases, enjoy moderate discounts, and high sales but unstable profits. Cluster 4 may represent the high-end market or large project transactions, involving high sales and high profits. There are 3 strategic recommendations for Cluster 0. Increase cross-selling, member promotions, and the regular push. And the first recommendation is pricing strategy adjustment, next, product mix optimization, and customer communication to promote the value of your product. For Cluster 2, it is recommended to standardize product promotion, make loyalty rewards, and do market research on such groups to understand their needs and preferences to better serve them. For Cluster 3, it needs personalized marketing, optimize the discount structure, and value-added services. For Cluster 4, it is recommended to provide one-on-one service, offer customized product or service options, and develop premium loyalty programs that include exclusive offers, event invitations, and other exclusive benefits. There are also some other explorations, for example, shows total sales by city. It can intuitively see the comparison of sales performance in different cities, helping enterprises to understand market distribution and identify sales hotspots. At the same time, adding total sales and average sales volume to the master dataset can facilitate further analysis, such as analyzing the relationship between city sales and average sales volume, or assessing market saturation and growth potential. From this figure, we can see that the top 3 cities with the highest total sales are New York City, Los Angeles, and Seattle. These cities may have greater market potential and a broader customer base. This indicates that there is high consumer activity and purchasing power in these regions. For example, New York City, as a metropolis, naturally has a large consumer market and diverse customer needs. This type of analysis is very useful for sales and marketing strategy development, especially in resource allocation and regional marketing planning. It is also possible to define high-value customers in a data set to maximize benefits and use the decision tree model to predict such customers. The threshold of high-value customers is determined by calculating the average value of sales and profit. Create a new column high-value customer in the data frame. If the customer's sales and profits are both higher than their respective averages, the column is marked as 1 indicating a high-value customer, otherwise 0. This table shows the model performs well, especially in distinguishing high-value customers with high accuracy and recall rate, which makes the model very suitable for identifying and formulating specific strategies for high-value customers in real business. The high accuracy and F1 scores indicate that the model strikes a good balance between maintenance, recall, and accuracy, with few significant signs of overfitting or underfitting. There are also some problems in this project, as listed above. They will be explored in future version. All in all, using GMM for making better strategies and making more money. That's it.